This is a production of Cornell
Hi there, my
University.
name is Zachary Stansell. I am the Hemp Germplasm Curator at the Plant Genetic Resources Unit, which is a part of the National Plant Germplasm System, which is in turn part of the Agricultural Research Service, which is part of the USDA. My background, I'm a recent graduate from Cornell Horticulture, where I primarily focused on Brassica oleracea crops, specifically broccoli. My work was done in support of the Eastern Broccoli Project, which is a 10-year study breeding, developing broccoli hybrids adapted for really excited to tell you a little bit about conditions of the East Coast. So we are in one of the Plant Genetic Resources Unit greenhouse in beautiful Geneva, New York, where we maintain a wide variety of different vegetable crop collections. So we have about 20,000 accessions that are comprised of about 300 unique species. Just like the other vegetable crop collections held at PGRU, we don't actively participate in plant breeding. Rather, we function to collect, conserve, characterize, and distribute these materials. So that's what we'll do with hemp as well. So we're acquiring materials from many different sources. A lot of our initial donors are going to be university level or private breeding companies that are working with hemp germplasm. The regulatory definition of hemp, which is given in the 2020 hemp final rule, which is defined essentially as less than 0.3% THC by dry weight. So those are the materials that we will collect, increase, characterize, and distribute. So much of the work that we do here will follow a very similar pipeline to how we would, for example, deal with the allium crops, brassica crops, tomato collections as well. So we maintain these germplasm collections for a couple reasons. One, to simply just conserve the crop genetic diversity of these many different crops. And then secondly, we're a working germplasm repository, so we make these materials available to many different stakeholders. So NPGS stakeholders are typically plant breeders, people doing basic science research, educators, and they use these materials to map important genetic traits or breed locally or climate change adapted lines. So all of these factors are very much true for hemp, which is really, this is the dawn of domestic hemp research. So having a vast collection of diverse hemp germplasm is going to be really fundamental in laying the foundation for powerful research in the decades to come. So hemp is a crop that has been known since ancient history. Nomadic tribes people in Central Asia used it extensively. There's strong evidence to believe that it was distributed along the Silk Road to East Asia, valued as to really many different areas, oil seed, and as a medicinal crop. The uses are almost hard to enumerate. So hemp has been an incredibly important crop in United States history. In fact, the $10 bill used to depict a scene of farmers harvesting hemp for fiber crops. So the USDA did maintain a hemp germplasm collection that included nearly 300 accessions. That collection was lost, and so this work is picking up on that effort. Unfortunately, we won't be able to recover many of those materials, but there's a lot of genetic diversity that exists in the world. It very much remains to be seen what the role of hemp will be in domestic and global production, but it's also extremely exciting to imagine the scope of possibilities that hemp materials could be able to address. So hemp is a very multi-purpose crop. It's used for fiber, grain, oil. It produces highly diverse secondary plant metabolites that we're only just beginning to understand the scale and scope of, that could be critical for medicinal uses or other phytochemical applications. The techniques that we're using on our basic research side. So MPGS and Plant Genetics Resource Unit is first and foremost a service organization. Like I said, we exist to conserve these materials and then provide them to the public. So in the meantime, we do in fact do some basic research, although that typically comes secondary to that mission that I spoke of. So in terms of hemp, we're really trying to catch up on lost time. This is a project that should have been in place for 70 years. So I'm trying to very rapidly bring this germplasm collection up to speed with, for example, the tomato collection or the apple collection, which we also keep here. So what that looks like is initially I'm trying to understand the genetic and geographical diversity of the broader pool of hemp germplasm. We have a lot of pieces of information. I've done a lot of work trying to assemble them together, build a database of literature, online resources, interviews with hemp breeders in other countries, assemble that all together to help me gain a more comprehensive picture of the broader pool of hemp germplasm. Secondly, I formed a number of really vital collaborations to assist in this project. So my role will be primarily to collect, increase, characterize, and distribute these materials, which will be made available on the GRIN Global portal online, which is an online database that allows users to query germplasm and make requests. So this tool also allows us to collect and aggregate large amounts of phenotypic or trait data. So these collaborations that I formed will leverage capabilities in other areas to collect and screen these materials that we'll be collecting and distributing. So for example, I've been working closely with a lab that characterizes cotton and flax fiber. I can send them materials from our work, they can characterize it for fiber traits. I will take that data and add it to the GRIN Global database to make it publicly available. I formed additional collaborations with analytical labs that will be characterizing secondary plant metabolites, as well as working with some groups where we plan to screen these materials for morphological and plant architectural diversity. So the goal is to not only assemble a diverse collection of hemp genetics, but a robust, high-dimensional set of phenotypic data that will accompany those materials. This is a brand new program, so we don't have a lot of historical context. A lot of this work was made possible by provisions in the 2014 and 2018 Farm Bill, and some subsequent legislation that really laid the groundwork for this type of project to even exist. For me, I feel like I'm breaking new ground every day. There's so much to learn. There's so many questions to resolve. Navigating a complex legal topography has been challenging. For me, I feel like I'm on many steep learning curves at once, but that's also exciting and where I love to be. This work has provided me an opportunity to ask many basic fundamental questions about hemp, scaling expertise from other areas, experts who evaluate fiber quality in flax. Flax is a crop that requires retting, similar to hemp. So what does the literature say about this? What are techniques applied to hemp that are to flax that may be applicable to hemp? Those types of questions. Hops is genetically relatively a close relative to cannabis. So is there knowledge from pathology work done by hop breeders or hop pathologists that can be applied to screening cannabis germplasm for disease resistance? Another accomplishment that I'm pretty proud of is I've been working with as many people as I can bring in together to develop a hemp phenotypic descriptor manual. So this will ultimately be a comprehensive and complete resource to allow the hemp community to compare apples to apples. How do you measure plant height? What is the best sampling technique for cannabinoids? What is the best way to assay fiber quality? Those sorts of things. Putting them all together into one combined PDF that will allow breeders and researchers to simply compare phenotypic traits across genetically and geographically diverse germplasm, I think would be a great value to the hemp community. And I've been really excited to speak to the real experts, get their thoughts, get their opinions, pull information out of papers, compare them side by side, and assemble this hemp descriptors manual. And ultimately, I hope that that information will be used to develop very specific mapping populations that allow us to tease apart the genetic foundations of key hemp horticulture agronomic traits. So work that I see long-term in the future, I would love to gain a deeper understanding of this wider pool of hemp genetic diversity and work with many collaborators to build that into a hemp magic population that segregates for many critical traits and captures the larger pool of hemp diversity. I think that would be an enormously valuable resource that I'd love to offer to public and private plant breeders, as well as those working to map plant traits. So as far as what the future holds, first and foremost, I just want to add more diverse hemp genetic materials to our collection while collecting as much phenotypic data to accompany those materials at the same time. So that's kind of goal number one, is just to scale, build our collection. I would also like to improve our ability to produce a lot of high quality seed. Hemp is a very challenging crop. It's dioecious, it's wind pollinated, so a lot of our typical greenhouse seed increase procedures are not applicable in the same way. Pollen control is of vital importance. So developing methods to handle those challenges will be an ongoing project. I'm also really interested in developing new collaborations and partnerships. I think it's exciting that hemp is such a diverse crop that's applicable to so many different industries and groups and stakeholders that I'd love to help harness the power of hemp's incredible genetic diversity to enable those diverse research projects. So please feel free to reach out to me if you have some great ideas. Another long-term goal is to develop a core diversity collection. What's a reduced set of hemp germplasm that can be used to capture succinctly the range of population structure that exists within cannabis. So there's also many more things that I'm excited about and look forward to in the future. But that's that's probably enough to keep me busy for a few years.
This has been a production of Cornell University, on the web at cornell.edu.